like I was saying, I am apologizing because I wanted to allow the molecules to settle. Because all of you were excited, you didn't know which one to take. I think you were even asking who gives more marks. I'm sure some of you don't care how bad a course could be as long as the guy gives little notes and whatever, and then you pass. So I wanted to make sure that I don't bias anybody by forcing them to do the course after the revisions. So when the students told me that this hour was now given up, then we used the other double, and the lady also told me that she can't use the SIM on Friday. I said, okay, now I can start so that we rush through. So I am assuming that I have not met anybody before, not in terms of electronics or whatever, but I met people on the 12th, last Tuesday, first Tuesday. But I came late and we started late and just tried to give an idea of what the course is about. This course is going to be a bit, not slow, but more, you have to be more thoughtful. Just as the beginning. So it's about the electronics, which we did last semester, and now we want to apply them to instruments, and then we do some measurements. This is how I can summarize the course, just to give you an idea of what the course is. When you are doing, for example, when we are using an ammeter or a voltmeter, we need to know the electronic, we need to know how the current works and how we are going to use this current, and so at the current we are able to measure it. And then we make the instrument, we design the coil, and then when we put in the current, then we are able to relate the effect of the current in order to give us the measurement. So eventually when you have this coil here, the moving iron meter, after you have put in the current, and here is the output, and then you have your coil here, the deflection you get after the current which came in, the deflection you get here would be proportional to the current you put in. So this, you construct this in mind with an idea of using it to measure the current, and the current, you know how the current works, because that's why we wasted a lot of time in understanding the electronic speed plus the electricity bit which you did. So here, for example, this is a core. You have the two magnets here. This takes care of the electricity and magnetism. And then the essence is how you are coming up with an instrument. And so that's why we call it electronics and instrumentation. Some universities, they say, they call it, I think even in one of these, one of the textbooks, I think, says it better, that principles of measurement systems, then electronic instrumentation and measurement techniques. So all we are doing, all we shall be doing is, can we try to build an instrument to do measurement by utilizing the electronics? So I don't expect anybody who didn't do, I think last semester, no, last academic year, I had a miracle. One one of the students had not done the electronics, but he came and did the instrumentation after he found out that he needed the knowledge. Now, I know it is your right, but I would wish to have people who really are here because of the word elective. It comes from electing. You are electing a course, meaning that you love that course or you have a deal for it. So I don't want you to be here, and then when it comes to practical sessions, you start going around and say, the man is giving us 9 practicals. I have already confirmed that we shall have 6 this time, and I'll make sure these 6 are done. And these 6 practicals, one, we shall have one which helps us to know about the 7 segment, with the sensing of, with the photodiode. So that's, I think, E19. We shall have E17. Then we shall have D4. The people who didn't get enough of the flip-flops. One of you said that you found D latches somewhere and you couldn't figure out what they are about. And then these are 3. So the other 3, there is an application of instrumentation, which is you are going to design a full wave rectifier. Your source. The other time we had it in E1, you would just connect. Then I come, I say, don't kill anything before I see. Now this time you are going to, you remember that adapter I showed you, the thing of the charger? So we shall give you a PCB, we give you a couple of diodes and a rod resistor, and then we shall use the transformer to test that you have designed and made sure that you solder them nicely. You will do soldering, you yourselves. You solder, we have the gun, we have the wire, we have the components. We have enough diodes for you to spoil. And we have enough boards for you to spoil. I will probably use Wednesday or a Monday to clarify on how you do the. So this is the experiment idea. It is already, they are already on web. That's why I'm saying that. And then we have the robots. There are 2 robots. And then for the robots, you have to be able to make the explorer and the line follower. The instructions are also on the web. Just to give you a glimpse of when we talk of electronics combined with an instrument, and then how we can use that instrument to measure. But in this sense, these ones will help us on a bit of transducers. By transducers, these you could say sort of a sensor. And here we have an input sensor, and we also have output sensor. An example of an input sensor is like, for example, a microphone. When you are on a party, you just hold your microphone and say, hello, hello, and it senses your voice, and then it gives, and then the speakers give you the output. So they sense that somebody is talking, and then eventually they give out an output. People who are not registered yet, so you don't rush it around. So I'm just trying to make, so I want you during this course, much as we shall follow the curriculum and whatever, but I want you to start thinking of how can I make a sensor? What can I do? I have it's maybe I don't want, anyone of you who knows where I stay? So I got solar, because if I say this, then someone may go, may tell people that that guy has a scarecrow. So I got a solar lamp, which it is made like a camera. So the LEDs are here. It has a sensor for motion, and of course the panel, the small solar panel, solar cell. I don't think it is a panel. The solar cell is here, so when it is during the day, this do not go on. And in the night, they only go on when there is some motion. Then it has some red light which goes on in the evening and keeps, so people think I have a CCTV. And I think they think I have. So when borders are passing, when you reach, it lights. And when they are sloping down, you hear them trying to make sure they dodge it, or they don't turn it on, but still it goes off. Like 30 seconds and then it goes off. I also had a chance to get some bulbs which were having a motion sensor, light sensor, and I think there are 3 things: motion, light. I think there are only 2. So if you move, it goes on. I think I still have some here which I can use to show you. Because whenever, some time back before I got those bulbs, a student would come and say, I want to make a project for some lamp that goes on and goes off. Then I say, but we want to make this, but these people have already made just a bulb. Just a small bulb. I forgot I should have, but I will come with it. It is like this, with a passive infrared sensor there, and inside here there are some LEDs there, but also on the side here there is a light dependent resistor which responds to the light. So if it is during the day, if it is on a shelf, if it is during the day, it cannot go on. If it is at night, it cannot go on until when somebody passes. So if you install it where you have neighbors who have kids who want to play, they come and do it. It goes on. Then when it goes off, they come again. They do it several times, it naps. With our power, I found those bulbs are reliable. Because of that, if power comes, because they are about 5 watts. It is energy saver, but also a risk to be spoiled. So this course shouldn't be theoretical as I will teach it. It should be that now I come here, give you resistors, transistors, and then I say make some sensor, anything. Now, what they call innovation is when you use what people normally see, and then for you get something out of it. So, last time I think I used an example of this door. If I chose to have this door and then construct this one here is the lock, for example. When I'm locking, so assuming this was my direct, okay? And the other bit here are the plates. So when you know these doors which lock twice, like you. Yes. So that means I can have a variation of the capacitance if my door is what? So I have, if I lock my door, I have the key, but some hooligan can either go to coffee and then I enable an alarm. Get idea? I connect a circuit
so that if the capacitance changes, then the voltage varies, because we know that Q is equal to CV, so capacitance is equal to Q over. So V is equal to Q over C. So whichever way, if I can have some steady flowing charge, and then I, using a dielectric, the lock as a dielectric, I change the capacitance, then I will interfere with the circuit, and then I can trigger the alarm. So if my voltage for no mode say was 5 volts, and then when the capacitance increases, it goes beyond 5 volts, and that was the threshold to trigger the alarm. So somebody will steal my key, come and is like, then the capacitance changes, and then the alarm goes off. I say, but I used the key. Because they did not know I had an alarm, which is like a vehicle. If I lock the vehicle with an alarm, even if it is silent, you come with the key, you will be able to open. And when you start to fidget with the door to open, because that was not the idea it should be, you should have first opened the door with the alarm, and then you open and then start the engine. Then when you start the engine, the alarm goes off, even if it was in silent mode. It makes noise. So making a sensor, anything can give you a sensor. When I drum, when I hit here, you have heard the sound. So if the sound was an alarm, to alert somebody, if somebody hits on the drum, people in the villages use a drum as well, as an alarming instrument. Others use it as a music instrument. So it is an instrument, but then you use pressure as the input. How you vary this pressure, eventually you get harmonics and you can make good music. I don't know whether I'm trying to make your mind open up. If I had, I can't remember how to blow. I told you, if I teach a course, when I finish it, I rub the head. So I don't remember anything in electronics. The same drugs. Yeah, the same drugs. No, when they were marketing the semester system, they told us, no, semester system is going to be nice because what you study, once you finish, you can even throw away the notes. But then when you check in this book, and you look at the top of a given course, like this course, PHY3115, Electronics and Instrumentation, this is what they call a prerequisite. PHY21111, PHY2215. I think even 12 should have been included. So how possible is it that you should have thrown away the books when the other one is a prerequisite? So it was like, once you have passed them, you can throw away the notes, but that's a lie. Keep your notes. I've never made notes since when I left school. When I was teaching in secondary, I was using my books for A level, even O level. In university, I think I have my notes here. These are my notes. They are older than most of all of you, except let me see. Most of yeah, I can tell you the date when I wrote these notes. I used to write dates in my notes. I don't know whether you do that these days, but this is 12th of October 2000. These are my notes. But now they are just for making sure. But the person who told me these notes is the person who eventually wrote this kind of module that we shall use, the ones which are on the way. So there is no. So I invested my time. You can see how we used to call it advanced electronics. How I used to arrange my notes. This is volume 1, and then I have, I don't know where the volume 2 is. So I got my notes, and I don't know, if I had not become a teacher, I don't know how I would feel. Because I used to write nicely. This is volume 3. And then I would now combine all of them, they are here. Volume 1, 2, 3. So anyone who tells you that when you finish a semester, throw away things, he's an enemy of your progress. You will by accident pass, and when you pass, you get a chance to teach, and then you are like starting from 0. You have no reference point, which may be okay. Okay, so that was just to make sure that you have a little bit of what is possible. So whether it is pressure, okay, I was talking about the, so if I had, for example, a diode, which is a photodiode, whereby when I put light, that's when it conducts. So if I put this diode in a circuit, and current to flow is when I have some light, that means I can be able to utilize it for knowing that in the morning, you have seen street lights going on in the morning, going off in the morning, and in the night they go on. So you can either use a photodiode or you can use a light-dependent resistor in your circuit. And the essence of in your circuit is the idea of the electronics. Let me put this one here so that I don't have to run it again. You are making an instrument to switch off the lights in the morning for streets, and then eventually it has to be some mean. Eventually you will have to do some measurement. The measurement bit is, you can use it an instrument to measure, but also you need to know how much. Something you need a word of measurement. Something like this. Either here. And for Agava, he knows that to make some of the measuring, to measure some of the things, you have to first know. If you go to the hospital, something that you studied in high school is what immediately is placed in your, under your armpit. And then they say, okay, hold tightly, then they remove, and then someone is, it's like, as if they are doing magic. But this is a thermometer that you were told, and the bulb was just there, so it immediately started expanding, and then gives the right temperature. So I want you to have that in mind. So for purposes of beginning the course, I will first tell you what is available. So on Wednesday, we shall again go like we were. I give 3 marks on Wednesday. The assignments there are for 3 marks. Some of you never got them actually. 2 or 3 I think. There are people who had not done the assignment, and I didn't have any sympathy. Just put a 0 through average. But no one, I think no one will took this course. I didn't want to have that long. Because you had been nice. At least you were good in the mouth. In the lectures we don't take tea, so I want that one to be clear.
lectures we don't take, probably we shall be able to take the platforms, but I don't know. The things are there, the cups are there, the kettle is there, the water is there, but I don't know about sugar. So where the course is ready, PHY3115, I already have 31 people. I can see you are, it's almost the same number, but I'm seeing new faces which I haven't seen on the way, but there are also faces on the way that I don't see here. So Agaba, when you were sending me a photo of your ID, you sent me, maybe it is an ID, there is a way you change it, you will have to educate me how to convert what you said for the, yes, so amidst you, you see a few faces which are new, which you bumped into during the exam, and then they are here, they are distance students. And distance students are here during this week, and I'm trying to make sure they chose to also do this course as well. And I'm trying to make sure that we do together before they go back and they will be following us on the way. Yes, Ronald?
It's an information here that you cannot enroll yourself in this course.
But you cannot enroll yourself. There is no option for enrollment fee. Paul, how did you do it? It's okay. We shall. For you, I'm not worried. I mean, I'm not. These ones are the ones I'm tight on. We shall fix because Mugume and Paul are there. They made it. I don't know what the challenge will be. So that's one. If I look through here, I can tell you the people who have not. Aston had not. He could be now by now, but he had not. And then Egan is there. John was the first one. Okilolu Solomon has not. I haven't seen him on the course. I know everybody. Then, Miro. Yeah, Miro. Miro had not been there. And then, got the last year where I don't know. The people who are here, the only additions are Miro. The only new faces I've seen is Miro, Paul, and Aston. Others are already on the way. So this is a good number. I wanted 30 sharp. But these are only 1, 2, 3, 4, 5. The sixth is anyone who is on when? I saw somebody with a laptop. Is it for fashion? Alcohol. Are you on the course? So the course has a course page. I just do it. I could have come with a projector, but I didn't want to come with a projector, and then it leaves the other. You remember that first day we met?
down there. Came with everything set up after I had set up. Oh, went and I went back local. I went back to the normal field. So there is a course page. That's where when you open, everything runs there. And then there is the course study resources 2025 and then 2024. 2024 is how it went last year. The way I taught that course from the beginning, lecture by lecture. Finish lecture, I go and upload. So this is going to be our first lecture in essence, because the other one was just to summarize. Then, so when you go to this, click here, the word is click here, and this is a hyperlink, meaning that it is clickable. Then it will take you to where there is notes, a button for notes, button for tests, then exams, assignments, I think, whatever, everything. Then there is, I have removed the lectures and I've just put videos. These videos are my videos, I think 8 years ago, 7 years ago when I taught this course. There are two or four lectures, 2 demonstrations with a robot, and then which one is? I think those ones. And then I have added what the university is paying for, but members are not using it. It's the Journal of Virtual, I think Video Experimentation, something like that. Journal of Video Experiments. So there is a group of people who have chosen to do experiments, and then they do experiment, it is filmed, they get data, they analyze the data, and then you see how an experiment is done. For everything, especially in sciences, biology, microbiology, engineering, electronics and instrumentation. So one of the ladies had come here once, some time back, and then another one is coming to check how far we are going, and they made for me a list of the videos related to our course outline. And then I put it here under this part. So there are videos for input transducers, then radiation transducers, thermal transducers, the mechanical transducers, up to the part of capacitive and that. Okay, some of you would say when we look at these videos, when he talks, I'm not the one. These are videos which are peer reviewed. Do you know the word peer? Not peer pressure related. This is peer reviewed. Peer reviewed means that people who are in that field reviewed these videos and passed them and say these ones are good for academics. So you will be able to access these international materials. YouTube has a bunch of things, but on YouTube you cannot determine which one is. Some guy will get a soldering gun, get a spark plug, put wires there, then he solder on a USB, and then he plugs in a phone and tells you, now we have created free internet. And you find a video with 1 million views. And YouTube can't do nothing. YouTube also benefits because it is getting that money, the money he makes on ads, YouTube gets a portion, I think 60% or 40%. So why would they be bothering him? So you can't trust what you find on YouTube unless it is from a well-known person or from a channel of a university or whatever. But even if it is a channel of the university, you can't be sure. But this is a journal of video experiments. If I got this right, Jove, it's just Jove, I think .com or .org. Whatever, when you search for Jove, you'll be able to get this website. And Makerere is paying a subscription, but I don't know how many of you have ever heard of this. Even me, I didn't use it so much last year because we had enough on our plate. Practicals, notes, then the videos of last year, videos of our own. So we didn't have time to go. So, but I have put this one there. And so on this course study materials, the experiments are there. You can see the experiments. The assignments are already there. But I have to edit a few things before you do. They are doable in the future, so you can't do them, but you'll see them. And then the notes, all notes are here, lecture 1 up to lecture 13. They are in form of a module. You start with the title of the lecture, input transducers, then you have objectives. What are the objectives of this lecture? And then at the end of each lecture, there are questions, sample questions concerning the lecture. And also these videos give a chance to have a quiz, so I will see whether I can create a quiz, if I manage to do it, so that I find out whether you actually did view the videos. And if I can also make it gradable so that it is part of the course. So that's how it is. So I think now I have at least highlighted what is available. So Mwere, you have now more than enough. This lady did me good. After giving me the playlist of this course, I haven't even checked myself. I haven't checked the videos, but I know they will be helpful. Where they are not able to do the experiment physically, I have rubbed this part of it. Where they are not able to do the experiment physically, they are able to make it like an animation. So an explanation, be able to make some, not cartoons. And then what I have forgotten on top of the course, I think here what is available is the course outline after here, course outline, and then the only video there is an AI generated video about instrumentation. And I think if you have watched it, it gives you an idea of where you are going. It talks about when you go to the hospital and you find those oscilloscopes, they are sensing, because they put those things on the parcel and so on, they know how is the heartbeat, how is the blood flowing, and almost everywhere the sensors are able to take the information and the doctor is able to see because of the instrumentation. Now we used the oscilloscope blindly last semester. We just got, then I tell you, put that. Then press auto set, then the waveforms come. But now, we are going to learn about an oscilloscope as an instrument. And then eventually we finish with the regulators, examples of regulators being like thermostats. You know, if you are ironing, you don't have to worry. You turn the flat iron, you start ironing. It heats up, then you hear, then the light goes off. When it cools down below the level that you had set the temperature, then it goes on. And then so the thermostat is a regulator. The fridge will be, then it shakes like that. Then the power is not in because the cooling conditions inside are okay. When the cooling now starts warming up and it is not normal again, then the fridge switches itself on. So you shouldn't do electronics and then you walk around. You can't try to get something that at least helps you to know what is going on. the idea is how do you use these components to help you get what you want and innovate something. Anything. So this AI video was like an advertisement. I wanted people to watch it, then see what is in the course. In a vehicle, you have, for example, an ABS sensor. When you stop abruptly, your car can't skid. It's just, you see it just stopping at the moment. If you don't have ABS, you can skid like from here up there because it will just slam immediately, and then the tires just become tight, and then all of them go around. So we nowadays live on everything is having sensors. We are still in a door in this campus which opens itself when you reach. At least we would get like one door.
Maybe you see technology department.
Yeah, like
it's one of the worst places.
That main entrance at least would have. So when I was in Norway, I used to be stubborn. I told the group which was here last time. So there was this door at the physics department. All of them almost were having sensor, but there's this main entrance on the side where there, I think the main entrance was this round one. This round one, I don't know how to draw it, but it has many parts. You come and turn in the then you exit. Then another one, when you are getting out, you go in the thing, then when you reach you exit. If you forget, you go another one. But this one was sensing, so you come and then, so me with my villageness, I would come and when I reach, I'm like, this opens wide, I slide in. But I don't think I had ever used that door beyond 5 p.m. I think whenever it would be 5, there was another side door which was mechanical. You slice the card, you type in your code, it opens. So I come in front of this huge Norwegian young boy, and then I reach out. You know, those days, no tie, like jean shirt, rucksack. So the thing had been locked. Now you needed to use the switch. There was a big switch there, big switches like this. So you tap this, it comes out again and then it opens. So this big boy comes and passes his hand behind me like this, and the thing opens. And then he sees me and smiles. I felt bad. With all my electronics, with what? I didn't, because I had not used it beyond, so I didn't know. So me, I came just to give a signal. So we have I don't know which sensor we have in this university. Where have you been and you feel you are utilizing the sensor?
Yeah, there are so many. Like when you open some doors, like those offices, you open a door, you don't need to, follow it up until when it closes. So you just open, even if you open it out of force, it comes back slowly, then it fixes itself. But there's so many, there's something up there because I just
here in our it was even everywhere. Each one of these doors had it's like a pump. It's like a hydraulic pump. So we had it in our toilet door, but then we removed the hook. So when you open the oil inside, the hydraulic stuff inside does not allow it to burn. So it keeps pushing. So it's like pumping the bicycle. So it keeps now going slow until when it reaches on there. So there's
for me, even the toilet seat, when you put like in the main building, you put your hands like there's a dryer or something like that. So you just put your hands and It brings up some heat.
These big men now who use the... I've not been in the main building since renovation, so I hear it is marvelous, but I've not stepped there. I've not had the... Okay, but you see, you don't know it, but the simplest, not the simplest, but the common sense that people don't see, and it is the most easily done, is the toilet cistern. The toilet cistern has a floater, just a ball, a plastic ball, and then where the water is coming in has a valve there. So when this floater is horizontal, okay, when the water is full, this part here hits, presses the valve and stops it. When you flush the toilet, the floater goes down and opens the valve. So water will flow in slowly until when it fills up. Then it forces the valve to go off. Simple. So you are using the buoyants to make sure that, imagine, maybe some other toilets have more sophisticated stuff, but this is, most toilets I've seen, most installations, it may look fantastic on the outside, whether you press to flush or turn to flush, still, but the inside is this mechanical. So this is, for example, mechanical sensor. Then the one which detects the infrared when you put your hands, and then it splashes the water for some time. So it allows the opening of the tap for some time, which is allowed to have, at least, especially when you go to the airport and like to avoid, even during COVID, most of the people had to install those things. I think even our sanitizer outside there was also would also be able to use that. So I'm not rushing to even give the detailed outline today, because I want you now to go rummage through the few things on welding, look at these videos, so that we rush. This time we don't have an excuse. The textbooks are there. The few textbooks we shall use, the copies are there. The way I taught last academic year is there. The experiments, we shall use the same trick we used of printing out the only experiments which are needed. And if you don't go beyond 36, I intend to have a group of 6, and then for the 6 labs, practicals. And then we shall normally use Wednesday. What do you have after now?
Computation of program.
Yes, it's not there. Is it a double?
It's there.
It's there.
So now.
It's online. On Zoom, on what? So
Google Meet. We use Google Meet.
Okay, Google Meet. Okay, so where do you do it from? Anywhere. So you are going anywhere. How does it do roll call? Because I'm trying to see how we can how I could use a few of the minutes.
They generate sales.
I am not, at least I'm glad that you are moving somewhere. By the time it comes back, we are moved somewhere. So we shall do 6 practicals, but apart from 19, apart from E19, others are duplicatable. For example, the robots are 2. So 3 people will build the line follower, as the other 3 people do explorer. Then I confirm that it works. Then you swap. And those who had built explorer, they build follower. Then I give you your marks. For the building of the IA, the instrumentation application, the one of making a full wave rectifier, we have enough. Each one of you will be, much as you are a group, but each one of you will be able to build a rectifier. And we test it. You solder, you put the diode and make it, you solder it and clean it up, and we see a nice circuit, and you can go with it at home if you want. So we want the technician, we agreed that we should make you do something so that you go away with some small skill. Last time you were now happy to be touching the oscilloscope. Now we want you to build something. So that's it. Please, those, yes.
I just have a question. We're studying space physics with Madam Elizabeth, and then she talked about something like if I have a remote and I'm going to maybe open a gate, when I'm not at home, maybe I have a remote and maybe I just press the remote. Like it sends signals to some satellite, and the satellite is connected to some chip in the door. So is that also about, is it also part of the instrumentation you're going to be doing? Is it also something like that?
We shall just talk about remotes, but the idea is that the only change is that if you, I don't want to talk and then someone reports me that I was teaching about terrorism. Terrorists use a simple technology that if I call this mobile phone, it will vibrate. And when it vibrates, it will trigger the switch of the bomb and it will blast. So he asks for his ransom. Okay? So he says, if you don't, I will blow it. So it doesn't need to be there. So I'm bringing that because at least you have seen this in movies. So it's the same thing. You are having a remote, but which remote goes to the satellite? Then the satellite sends the signal to the door. You get the point? So the same way we subscribe to the satellite TV, for example, when your thing is used up, when it is over, you go to mobile money, you subscribe, your money is taken. After it is taken, then immediately they say either it restarts itself, and you start now watching the premiership again. So the link of remote when we are face to face has now first gone to the satellite and then gone to the gate. So that's how some of the CCTV works, that you don't have to be home. You can still use the internet, and now you're able to see what is going on at home on your cameras when you are away via the app. It is about the instrument and then the signal that you are using. Yes, Adam.
I have maybe two things. Number one is a little bit distant projects. This year we will do projects.
There is a coordinator for projects, but as my class, I would be able to. You should start now.
That's why I'm asking.
So if you should start across the courses. You should start looking at which course can result into, because the reason I'm not into it, this will be my third, this is not the third time I teach the course, but one time I taught the course and almost all students did their projects in instrumentation. Last year, these finalists who went, almost all of them also were doing, not that they were doing with me, but they were doing projects related to electronics. And sometimes I don't want to appear as if there is something I do to make students, but which is okay with me. That means you would have understood. So you should start now. That's why I'm doing this, showing you the door, making you now realize, can you innovate something to solve a problem beyond just applying electronics into an instrument to do measurement. And so, but I will be hinting on it, but there is an official lecturer for projects who should be able to be the one. But the official time for projects is second year, but I mean second semester. But you can't have enough time in second semester to think of an idea and then get a supervisor and then implement the idea. The earlier you start, the better. To think of what you think can make some appropriate project. So I wanna stop, since you are saying that you are already on Google Meet. So we do Friday, we do start, and then I will elaborate more like I did in electronics. Each section of the course outline, I will be expounding on it so that you know what it entails. And then after Friday, I will want to confirm who is with me or who is not with me so that I prepare accordingly. I don't want to prepare lists and then the next day I say, but sir, I want to be with people, but it is your right. I do not force people in or out. It is your right to be or out. So we shall be using Wednesday, if all goes well, if the numbers keep as I'm seeing. We use only Wednesday. We split the experiment so that you are 3 per set. 6 on this other one, it has parts, each one will be able to understand. I'm very sure it's demonstrative. So the experiments we are doing this semester are demonstrative in terms of the applications of operation amplifiers, the photodiodes, and then the robot, and then this one of soldering by yourself to get a skill. And then the theory, we shall try as much as possible to understand the theoretical concepts. Any other question? You had 2 things, but you asked only one. The other one is this time.
I was still thinking, it was related to the project. There are some things I want.
Okay, so I must say that thank you for coming. This is the only course I have. So if you were only 2 or 3, I would feel guilty, but I would be happy. So please, those who are not on Mwere, by close of the day, be on Mwere, fill the Google form and upload the front page of your ID, not some photograph.
I did by mistake.
I understood, but I needed
I
you.
cannot edit it.
You can't. You have to send another one.
Yeah.
You have to fill
Fill
another
another
form.
form.
Then I will delete this other. Okay, so I can remain. Do you have a lecture? Anything. So I can remain with the distance people, and others you go for your. Sorry, he's hearing me.
You're already in the lesson.
Okay, so you go wherever you wish to continue with the lecture. And then I remain with the distance. just remain 3. Are you laughing? I used to be so interested in many numbers, but also I'm growing old. By the time I leave here, I feel the back pain. So, and then when it comes to marking, it becomes a little bit cumbersome. So the reason I'm saying that we remain at least for like an hour is to make sure we simplify a few things. Not like these other kids when I'm talking, I know they will go, but remember we did not do much in electronics. So we may need to so let's actually do the course outline. And Friday we can do the course outline with the other ones, or we can do something else, or choose to use another time. But let me try to explain a few things with you, even if you come and we will go through again. But if you are adding to somewhere else or doing something else, you tell me so that I don't waste your time. For me, I feel like it is now, this is 2 to 3, 4, it's okay for me. Yeah, so like I said, this course mainly is about the sensors. This is the most thing that I should clarify. And see, a sensor can sense an electrical or a physical signal. So any of these can be sensed by a sensor. When I'm talking through a microphone, I'm actually sending pressure. I'm compressing the air. Like when I'm talking now, the camera, I will be pushing this air, then it goes over the rarefactions, and then it reaches the microphone, and then that gets interpreted as an electrical signal. It goes in after getting interpreted, and then it records it on the SD card. Now, when you are playing music on your, so in an input the input sensor, which we make to look nicer and call it a transducer. This transducer can be either input or an output transducer. And that's why I say that if I am talking into a microphone, the microphone is inputting. So that's an input transducer, an input sensor. So this is, for example, microphone. And then this one is the speaker, which is an output transducer. Now, in this course, this unit will introduce you, the students, to the physics of basic transducers and their use in electronic circuits. This one here, in some of the experiments, you find that they are using what they call, I don't know whether this is the spelling, but the buzzer. The doo, so if you ever use that watch, that melody watch, and then when it reaches time, then it either sings or beeps, that's a buzzer. So a buzzer is also an output. It means a signal came in, alerting you it is time, and then it makes the noise. If I put an alarm on the car, and someone comes and bangs the car, then it makes the noise. The alarm speaker is the buzzer, it is the speaker. But we are used to the speaker, which we use either these speakers of the Muslims on top of the mosques and the like. So the course is mostly about how do we use these transducers in electronics to build instruments, and we use them for measurement. So if I put an instrument, if I wanted to to measure the sun duration, I can say, okay, I'll put this, if I want to know the intensity, can I know how much this sun is changing or is inducing, not inducing, but creating the current. For example, if I put a solar panel, a solar cell, which is a junction diode, it's a diode in a sense, and then it conducts and gives me a current, and that current I'm able to know how much sun it is, how much is the intensity because of the current has been able to produce. So it was, for example, that lamp I told you about, when it is during the day, it cannot go on. So the panel, that solar cell, is acting as a sensor. Much as the sensing is being done, and not unknowingly, but for it is charging the battery is in the lamp. But the circuit was made in such a way that when the charging is being done, the lamp cannot go on. You get the idea? So a sense, you can make a sensor at your own will. Maybe Gume can explain to us, for example, when this guy was talking about that, I think even the Yaka works like that. You buy a token, you put in your, is it Yaka now or light?
Light.
Light. So if I am ironing, I also still buy light. So, because at least for Yaka it is both. You can Yaka when you are cooking, you say, but the light, you say light. I am buying light, then you want to iron or cook with light. So you put in, when your token is over, the switch is flipped. And then when you load, after loading it goes on. But you bought the thing from online. Then depending on whatever technology they are using, when you load, the thing goes on by itself. You use your stuff up, the switches go off, and you have nothing to do. You put the thing up there, you have to climb there if you want.
That Yaka uses the internet also?
I don't know what use it is. Is it connected along one of the lines as communication, whatever? Does it use wireless? What does it use?
It uses signals.
Via one of the neutral or what? Across?
From the meter to...
That one has a wire which is for interface. But
sometimes there are those which are wireless.
yeah.
Yes.
Yeah, but we are talking of beyond these two.
Beyond these two.
Yeah, beyond the meter at the pole and the unit inside. How is the intelligence it uses to know that now this token is right, and then it sends a signal to flip off the thing, and when you put a right, so also you don't know.
All those things are the electronics now we are studying. So
I'm the one who is supposed to know.
Yes. No, the challenge we have in Uganda, we don't study engineering, those things. They just bring the instrument
And say, do this.
This operates in this way, but we don't know how it is built.
Well, the problem is, how can I call it? The problem is that they are trying to guard, like remember by then as South African, they were guarding. You tell them how everything is done, they cheat you. So they now make you just use mechanical. You are just say switch on here to do this. Even the people who install, just make sure this is put here, this is put here, this is put here, you are done. But I think there was a time when they were running an optic fiber cable along the line, especially when they brought these insulated wires, cables. But also someone, as if I will check, I will find out, but as if somebody said they were utilizing the neutral for the signals across the...
We have a section for the meter labs, laboratories.
Yes, for the...
And some people have gone on even to cheat the
Yes,
use
so-
of electricity through that. So
Yes, so that there was that part which at least which uses that that neutral signal to make sure that they can be able to have them communicate along. The things which sound like you are being smart, I don't like normally to talk about them.
but there's a possibility of fiber optics.
Yeah, but still it is about fiber optic communication. You do Maxwell's equations, so I don't want to go into that. So the best transducers we can look at is, we have radiation transducers, thermoelectric, mechanical, capacitive, and then inductive. So we have these transducers. The course is about transducers, but they could be radiation. When we talk of radiation, we talk of the light, and you know light is a range. You range from infrared, I think, to microwave. The shortest is microwave, and then the longest is infrared. So, and then with your visible light, somewhere 500 something nanometers, where you are able to see things. So you can utilize this radiation, which could be light in its sense of visible light, or infrared. Most of the remote controls are infrared. You don't see anything. You see the light here trying to light, and the other one also blinking, but you are not seeing any light going along. And then so they could be thermoelectric, they can be purely mechanical, then you can have the inductive, you can have capacitive, and then which other one? Then the other one is thermoelectric, mechanical, capacitive, thermoelectric. 1, 2, 3, 4, 5.
Looks like those ones we just buy them. No,
So-
make it.
So this is the idea. You want to make an instrument, you want it to measure something, and it is electronic. What do you want it to use?
Solve problems.
You know what I'm saying? What signal do you want it? You want to solve a problem, but what do you want to solve? So if you press on the brake, that's mechanical. Then now the brake pedal will experience your mechanical force, distribute the hydraulic fluid. The hydraulic fluid will press the pads, and your car will stop. You have an instrument. You have the braking instrument the braking system as an instrument. The measurement part may not be there for now, but at least it is able to. You press on the accelerator, the gas pedal, the fuel is injected in, the engine turns, the vehicle moves, and then you are able to have an instrument called a speedometer, which is taken care of. So you find that somebody decided to make sure that on the tire there is a magnet, and then inside there is a coil whereby when that magnet passes, an electric signal, a voltage is built up. That one is able to be turned into how much revolutions are being given on the speedometer. So you are driving, that's why some vehicles will be running very fast, but the speed is seemingly as if it is low, but the thing is running very fast, like if you see these vehicles with turbo. So if you look at a big vehicle, if it is going to be relying on that turning of the wheel. By the time the wheel goes to make sure the speed is actually high, that's why you find a vehicle with 250 kilometers per hour. Like these Subaru people. You find that it is able to maintain that because of other issues like stability and how they built it. But at the end of the day, you are able, so you have to think of what am I able to use some light? And then that light will be able to create a signal, and that signal. So that's why I brought in the idea of, for example, we shall look at the photodiode, and you remember we did look at the phototransistor, okay? You remember? We had the junction. If we had this PN junction, I mean this, yes, we had a junction here, and we say if this junction was being activated, if the base current was being activated by a phototransistor to then make sure that it switches off or on this transistor depending on how much current you are, I mean how much light you are shining on. So if there is no light, there is no current, so the transistor is off. Then if the light comes up and then current starts flowing, you can utilize that current as an off, whereby if you had a current which was supposed to be flowing in here, and then you now have this current being provided by this phototransistor, it opposes this one and pushes it back. And when it pushes it back, then you get the circuit blocked. There is no current that is completing in the circuit to put on the lights which were on. So they go off when light comes, and then they go on when the light goes. So it's the reason we don't innovate is because we don't care. I can find my fella in my tree ripe and then I chew. I don't need to worry, you know.
There was this machine the police traffic officers use.
The one for speed gun. So the speed gun uses they call it, forgotten the name, Doppler. Yes, the Doppler effect. So he sends the signal to you and then receives the signal. And then is able to calculate the one that it sent and then the one it has received. When it sent it to you, you were there. Now by reception, by the time it reflects, it is at some point, then it calculates the difference between the first position and the one where the next one it got. And then it will say, no, you are moving at this speed.
All that in how many seconds? Just a few seconds.
Of course,
Depends on how fast.
the faster you are, of course, that's the essence. And they do not point it at you when you are there. They point it at you when you are those. But people have a theory that if you went doing wipers, you will distort the signal. But if you do that, the policeman will still grab you. It will not get a good measurement, but they will grab you because you are distorting there. Because if you put wipers and they are like this, then it cannot get the exact object to reflect back. So that's an example of an instrument which is also depending on that. And I think in one of the videos of this place, the Jove, they explain how you can measure distance electronically. You can use light waves, you can use microwaves, or you can use the sound. And I think what you were used to was the sound one. You stand in the Kasuri. I stand here, you go to Kasuri, I get a stop clock, you shoot a gun, I see the light, the cannon. When you shoot the cannon, I see the light, I start the clock. I wait. When I hear then I stop the clock. I know the distance between us, between here and the Kasuri, and then I calculate the speed of sound. It's a sensor. You have made the sensor, and saw the light. Then you have to have a sensor which is able to hear the sound, and then those two tallied, the distance is already known, and then you get the. You remember when I was explaining, you were not, maybe you were there, you hadn't left. When I was talking of how a satellite works, how they go singing PVT, the position, the velocity, and the time. And depending on how you feel, you find out that actually I'm in the middle, or I am near this one, so you get your position. Because now you are able, the other ones are already telling you, I'm here, I'm moving at this time, and you say, hey, I'm here, moving at this speed, in this, and the time is this one. Hey. Then you eventually be able to know exactly where somebody is positioned. So, thermoelectric is when you put electricity, it can produce the, for example, an indicator of a car. It's just a bimetallic strip. When it is cold, it bends. When it is cold,
It is flat.
it is flat. So we can say that when it is cold, that's when the switch is on. So assuming this is the contact, it taps here. So when you switch it on, it warms up. Depending on, so this one expands more, less, and then this expands more, then it bends this way and breaks the contact. So when it touches, it hits up, then the indicator is off. Simple. But now you can see people have nice vehicles. You see the LEDs lighting like this, even with another light like this. So you cannot now say an indicator is made up of a bimetallic strip. It is now beyond that. I think not mechanical, not what I don't know where to even place it here. Because once you switch on, then you remember the register when I hinted about the shift register when I was showing you that signpost we tried to do. So you get the LEDs lighting in a sequence, the last ones then show, the arrow shows, then they start again, and then that's now how people's vehicles have indicated. But it's a progress. You keep the one who, imagine someone just said, if I use a bimetallic strip, it will hit up, bend away, come back, bend away, come back. And the vehicle can provide that power. Even when the battery is really so bad off for the vehicle, you'll still be able to put hazard, and they go, but at least they show some light. Yeah. So inductive and capacitive, especially in that, for example, in that capacitive, even your phones now when you are sliding, it's sliding, when you are scrolling on your smartphone, you are using the capacitive because you are trying to change the thickness of the plates of that cover. And then we have inductive. But also with capacitive, we can just utilize the simple analogy I was giving. The analogy of that door, whereby the lock is directive, and then where it is locked, where it fits, you have your two plates, and then when you lock, you fit in. The capacitance is at a given value. You remove it without switching off the alarm, so somebody is breaking into the house because it is not, they are not supposed to be there. If these padlocks, I don't know how the padlocks work, but there are padlocks which have alarm. If you come and fit it without switching it off, then it makes noise. So it is the person, the one who locks the padlock, puts the code. So it's until when you unlock it that you are able to open it as if it is a normal. So somebody may always see you It's like a vehicle. If you always close your vehicle with another remote control button in the side, some people may never ever imagine that your vehicle has an alarm system. And then until when they come to do vandalism, and then it starts yelling. Unless if they always see you having the lights, you know. But some vehicles, even if you just lock with or open the indicators, will show as if it has an alarm system. So in mechanically, like I talked of, you can make a sensor by utilizing the idea of these plates. You have your plates here, and then you have a dielectric in here, which you can vary. So it means that when you move if you move this either out or in, you have a change in this distance here. And that one, this change in this distance here, with the area here, so you know C is equal to epsilon A over D. So you can utilize the going in of the dielectric or going out of the dielectric. That can vary the capacitance, and then it gives you a signal which you can utilize. It's all about how you respond. They say that people, you can be affected by people by how you react. So they say how you react to people's opinion is what determines how your mental health is. So there are people whom you abuse, the guy just laughs at you. Then there are people who are abused and the man falls asleep. You cannot call me a fool. How? Are you the one who produced me? And then the fight ensues, and it is a chaotic situation.
And bloody.
And blood. Another one, you say you are a fool, he says, thank you, sir. And he goes on. He goes, picks his bottle of beer and drinks. That's no problem. And I think Ronald is like that type. Whichever type he is. Or you can just, without a dielectric, you can take the advantage of the. So, for example, if I say I want to make a bridge, a weighing bridge, which takes care of how much heavy a truck is, and then I make sure that the way the bridge compresses depends on the tonnage of the vehicle. And so when the vehicle is light, they think there's the D is big. When the vehicle is very heavy, the D decreases. As because now when the D decreases, the capacitance increases. And then from the C is equal to Q over V, or which is V equal to Q over C, then you can find, you can use the voltage, because voltage is the one which is always used in electronics. Because voltage you connect voltage across a resistor, automatically you have current flowing. And the current is like, if you watch that video I put, current is like the water in the pipes. So as long as it is flowing around, things work out. Get the idea? So it depends on, and so for example, the other one is the cylindrical capacitor. The cylindrical capacitor, some people use it in, it is the principle on which the fuel gauge works. If you have the big tank of the fuel, and then you have a small capacitor like this one, and then you have like an inlet that is able to. So if you made sure that the way the inlet is when the other tank is full, this also is full, and as you draw the fuel, this one also starts decreasing proportionately. So it means that at one point when, for example, the liquid is up to this level, then you are having this part here, the capacitance, you have now two capacitors from electricity and magnetism. You have the capacitor up here and this one here, and these ones tend to be, I think, in parallel. And then you find that the capacitance changes because you have this one being empty, this one has a dielectric, one which has a dielectric is higher. So then you are able to have variation in capacitance. So it's about how you are able to get a response from what you are feeding in. You feed the light here, the photons are emitted, and then the current starts flowing. That current meets the current here, opposes it, and instead it turns this other side and puts on switches on a LED, which shows you that now there is a problem. Or triggers a buzzer and starts beeping. So if I was to put, for example, a light here, a light source here, and a photodiode here, and they are facing each other, and as they are facing each other, I'm having a consistent current flowing, and then an intruder comes and crosses through. So when that intruder crosses through, stops the current reaching, stops the light reaching here, no more current is flowing, the current flows in the buzzer, it makes noise. So I know somebody has an intruder into my house, an alarm goes off. And you can now program. So this is the beauty of instrumentation, that you find that not long ago you would buy a laptop and you have to install drivers for flash drives in order to use it, because it is an instrument and you need to know what does this do when I use it. So you can find that now you make sure your buzzer goes, you can program and say the buzzer goes off when I restart. That's why we are doing the D latches and the flip-flops. Can you store a state and make sure that you have to reset? You remember when we were trying to do the reset set. So the set was the moment the intruder cuts the current and the buzzer is on, the buzzer goes off once the switch is put off by the person who set it. So until reset. So if somebody kicks your vehicle, some vehicles will cry until when somebody comes, switches it off and then engages it again. Yes.
How do the capacitor banks work?
Capacitor is a storage. It's a storage. The car battery is a capacitor.
Like the ones for which they used to correct the power factor.
The one of experiment E1.
I have not checked through the experiment.
No, E1 we did it. Only that we didn't do it. The rectification, we had the part where we were smoothing the rectified voltage. And that meant that you are making sure that some of the voltage, the capacitor gets charged up, and as it is discharged, so you have a smoothing as a filter. So that's how some of the capacitors are used. You use it to make sure that it's like how I've lost two alternators for my vehicles out of stupidity. But to me, I knew I was being smart. So I thought I could reach home. I should leave my terminal loose so that when I reach home, I'm able to remove it. And when I sleep sound. I'm not worried that the vehicle is taking a lot of, my battery is draining. Now, Then when I would be driving, I would be blasting my music to the top. I have a driving car, a dash cam. So now I was always overloading the alternator. And the first time the alternator blew, it was like I was looking around to know whom I greeted before going home. Who is the Xirani? And then it ended in tears. I had to change the belts, and as we were changing the belts, finally is when this guy turned off the engine, and then when he tried to pass the spanner on the alternator, there was no attraction. Because when the alternator is working and there is charging, it should be able to attract. It should be able to, because it is now moving, it should be able to make a magnetic field and attract some metal. So we ended up going to now the repair it. So I didn't know. Me, I thought it was the issue of the belt. So of recent, I mean the other vehicle, which I was also doing the same stupid thing. And then I reached somewhere, I think, after reaching there, I wanted to heat up the cabin very quickly, put 30 degrees, then opened all the in holes. And in a few seconds after doing for some time, the battery and the engine shows up. I park at the petrol station, I ask the guy says, no, there's nobody. I say, fine. So they say, but there's a young man who can, young man comes, we switch off the engine, we remove the terminal, we put back, troubleshoot, start the engine, the things remain. He said, you drive home, no problem. They will go off. I drive for some distance, I reach somewhere, the vehicle is not moving. So I branch off the petrol station. I left the vehicle at the petrol station, jumped on the border, went to the taxi stage and went home. But then, it is through this young man which I found there, who was trying to explain to me, but you know when your head is like this. And so he was explaining to me that if you remove the battery terminal and the engine goes off, that means it was not working. The reason of going off is that if the alternator is not producing electricity, the EFT, the electronic fuel transmission, cannot work because there is no power to, because you have removed. So the engine can no longer get fuel to continue running. But I told him, no, but me, one time I used to move with my battery in the vehicle. When I was using a different battery for this vehicle, I would start the vehicle, put the battery inside, and then go wherever I'm going. And as long as I would not switch off the engine, I would reach, switch off the engine. Then in the evening when I'm going home, I just put my jumper, start, put the battery there, and go home. And charge the battery at home with a solar battery. And then, but then, when we were jumping the vehicle to get it off the slope, to get it inside, so that before I left it. So, I think that's why they say sometimes educated people are confused. So we are jumping the vehicle, and I'm telling the guy, put here on the terminals of the battery. I go the other side, there's nothing, not even a single light. Because I'm removing the terminal, he's putting on the battery, the terminal is removed. What are we jump starting? The battery or what? So until when we were hopeless, like we had no more hope, that I put the terminal and tighten, and then I said, now let's try the last time. So I turned, the lights are on, I think it is because of the old battery, the old normal, and then it started. And I'm like, yeah. But then when I now understood what the young man was saying of removing the terminal, so I removed the terminal, they also the engine. So the guy went, picked it up, took it for repair. So now I can't remove the turbines. Because the idea is the vehicle uses the 12 volts and it should be constant. And that means that's why it should come from the battery. Now, if the other one is too much, it only ends up on the battery, but cannot go in the system. Because when the battery is on, everything comes from the battery to the system.
Okay, you say the battery is like a capacitor.
Huh?
You say the battery is like a capacitor.
It's not like it is a capacitor. Yes.
Those 2 plates.
Capacitor is a device that stores charge, and the battery stores charge. So it's a lead-acid capacitor, which we call a battery. We call it an accumulator, whatever you want. Voltaire started from there, seeing the kick of the frog, which had died already. Then he looked at, because he was using a tweezer and a scissor, which were different metals, and then he tried now to see whether it actually is true, because he had killed the frog. And then he started getting some jelly, okay, some juice or fluid, and then made some current. And then that's how Voltaire put cells together and made the battery. Eventually, so the course also, after these transducers, we look at the elements of a communication system. So a communication system is if I can make sure that this microphone here and then the speaker in someone's radio, if the two can communicate, then I would have made a communication system. So you go to a studio, in a radio studio, in a TV studio. When you go to the TV studio, radio studio, let's focus on the voice. They will hook on a microphone on you. So you talk in the microphone, it goes in the system. Gets to be made an electronic signal. Then it gets decoded if it is going to be, for example, satellite transmission or digital transmission. Because the decoding is, you are trying to change from, remember when we were doing digital to analog conversion and analog to digital conversions at a high speed during the course, the last course. So you change you decode it, something which was just varying in my voice, which was varying in, I'm talking, you are hearing me because I'm pushing the air around randomly. There's no uniformity. But the moment it pops in the microphone and goes to the decoder makes it a digitized version. And so you have some 101010s arranged together to make a binary code. That code then now gets to be boosted by a transmitter. If we were using analog, then it would go straight to the ionosphere and then gets totally done and reflected towards the receiver, which is the antenna of the radio. So you have a radio antenna, and then you have the CRL, and then once you have this signal reaching the antenna, it induces a voltage. After inducing the voltage, it comes in here, and then you have this current here, this current I and F, and then at the fundamental frequency here, this fundamental frequency is equal to the frequency of the, I think it is megahertz. It's the frequency at which the station transmitted that. So for example, for frequency modulation, which is the current modern way of communication, you have the frequency being the one which is being modulated, and because it is point to point, you get the signal, and then you have the F naught equal to, I think, 1 over 2 pi, 1 over 2 pi root L over C. Is it L over C? That is where XC at fundamental frequency. And then you receive the signal, you receive the channel. For example, this is 88.2 megahertz in Sunway FM. And you get the best music around now. So that's a communication system. It started by having an input transducer, then it was decoded, it gets modulated, either by modulating the frequency or the amplitude, but we no longer really know AM. You can't talk of AM radio of recent. We talk of the FM radio. So it can be modulated using frequency or modulated using the amplitude or the frequency. So for the FM, if you modulate it, then it goes, and then you demodulate it. And currently, you know, I think either Impact and Radio 1, they also put on DSTV and free to air. So you can get the radio on free to air and get Radio 1 because it is being demodulated, modulated, decoded, encoded, it goes to the satellite, then it comes down, gets decoded, and then you receive it with no hassle. So you look for the channel like any other channel, you reach on the radio, and then you get your Radio 1. But you know the quality, you don't get the quality like the one you get in FM. When FM came, it was like you are playing a cassette. The bass is there because you are just modulating the frequency. Everything comes out crystal clear as long as the radio is point of sight, because FM cannot bend around objects or whatever. It has to be point of sight. That's why you have capital in Kampala 91.3, which Mbarara is a different frequency. You get to Mbala, it is a different frequency, because now you are just trying to make sure that you get that signal through via, you can use now via the internet, and then when you reach there, you broadcast it. You repeat the same process of input. So in between the input and the output is where we have all these things of transmitter, demodulator, modulator, then amplifier, all sorts of things. And that constitutes of the communication system.
You have talked about internet. Nowadays you can listen to a radio station on internet.
On internet. You just go to a website or an app, and then you get all the channels you want. And you listen.
That means it is not like our analog radios you move with.
It is, you see, you have this system. Someone talked. And after talking, then talks into that signal now gets fed into an internet line. Whether it is 4G, whether it is wired one, but gets fed into an internet line. And that internet line now transmits to those who can receive the internet by whichever method, whether they are using the cable, whether they are using Wi-Fi, or whether they are using 4G on their phones. And then your phone now, that's why you need an app on your phone to decode that message and change it from 101010, and it goes through either the speaker of your phone or your headphones, and then comes out as an output transducer, through an output transducer. And that now becomes a communication system. So when we talk of a communication system, we mean all these things that we are placing from when the voice, when my input signal has been put, and when my input signal has been received by somebody. If I'm calling you, this is a communication system. But look, I am saying hello, the thing is going into the phone. The phone now is a coil, and this coil here will now go, you will study this in electromagnetism. You have this coil 1, you have this coil 2, so when you change the electric field, the current here, So assuming I put this other coil through here, that change in electric field, it's changing field now induces a current here. And so when I call, my calling is changing the current in my coil. Then that change in magnetic field induces a current in your form. But these two coils are not strong enough to build up the current that will trigger the ringtone in your phone. So that's why we need that booster there, those boosters on that mast, to make sure that they expound, they enhance this magnetic field here. That's why we call them cell towers. So we call it a cell phone because each cell needs a tower to provide, to make sure that it enhances this interaction between these two phones. And so we say we don't have network in this place because there is no tower to enhance the signal to cause the two phones to interact together.
But doctor, the network, the signals can be blocked by some.
Yeah, because if you put something that shields this field from interacting with this coil,
So you can lose network by
mere having no access to the place. That's why people would climb the tree to make sure that now the fields are able to reach. In just your distance, I don't mind. In electromagnetism and electrical magnetism, we have this Gauss's law that the more you want to make the electric fields go farther, you have to make sure that you have enough charge density. Okay? And you must be cognizant of the environment you are in. That is the permittivity. How is the environment you are in permitting the electric fields to go through? And this is the basis of communication, that we all make sure that our transmitter, like my Wi-Fi antenna, must be able to give these electric fields. But as they are going, how are you able to make sure that you sustain them? The charge density is how much you can produce this electricity, because the charge density is coming from the charge per unit area. And then how is the material in which you are? So if it is, that's why if it is raining, then your TV image starts doing this, shaking, and sometimes spots remain and not disappear. And then sometimes the image just becomes stuck like this because you are not able to have the field lines to which way they are. Okay, so I don't know, we have used our 1 hour which we report. So I wanted you to have an understanding, and then finally under the course description we talk of the elements of the communication system and then some examples of measuring instruments and regulators presented. So we shall start with the other ones as if it is normal, but I wanted you at least to have some more tentacles on the course, because for them they just want to chop and finish. When I come, what I give them is what they take, and then wait for exam, they produce, then pass. But then you will soon go and you will be alone. So we needed to have some kind of memory that you will be able to remember when you are out there doing that. So the course is basically, under normal circumstances, this is a course which is taught to, I think, a group of students, those who are doing like biomedical engineering, those who are doing laboratory techniques, those who are doing medicine, to make sure that they can use their fields to produce some instruments. How can you measure, for example, temperature of a person? In the COVID, you could not start getting a thermometer and say you open and pull. there was distancing. So that's why they were now getting guns, and then they point at your. Then now some people are saying that gun is pointed at your whatever gland, it kills whatever, makes you dumb. So you need to know what you are producing, what is it that you are taking advantage.
Some people are doing this for Illuminati.
So anything could happen. So that's the introduction of the small course description of the course. The objectives are that you will be able to have an idea, to be able to differentiate between input and output transducers. I'm sure now you can gamble in differentiating between a speaker and a microphone, and explain the general principle of transducers and the basic building principles of the communication block. And the communication block is when you have these things of input. Okay, you start with a signal by talking. It is a talk show. The guests in the studio. Then input transducer, the microphones. Then after the microphones, you have heard of the words like multiplexer, mixer, those things. Mixer, multiplexer is when somebody is now adjusting some frequencies to make sure that the sound is nice. And then analyze amplitude modulation and frequency modulation. Here, normally these days using Fourier transforms. Here, really, these days, AM transmission, teaching it to you is like wasting time. We are far away now. We are on apps. We do everything on apps. We even know more radios which are AM. But I used to use AM radio. Then we used to have shortwave 1, shortwave 2, AM, FM. So you find somebody boasting, my radio is a 5 band. Shortwave 1, shortwave 2, shortwave 3, FM, AM. Sometimes I think there was AM1, AM2, so someone's, and for them that is like, but it was just about being able to get some signals because of the diverse way different stations were broadcasting. Currently I'm having that challenge, but I don't know who can help. If you are using free to air, you get some channels together, they are clear. But then the other ones cannot be there. If you adjust and the other ones are clear, these ones are not clear. But you are using a satellite, we are using satellite signals. We should be able to have all of them clear at the same time, because we are using the same decoding. You cannot tell me that now analog we will return, because some would afford VHF, very high frequency, others would afford ultra high frequency UHF. Whichever you take as the strongest or the best, but this is the reason we went to digital and satellite TV was that now we can be able to transmit as many channels as possible, which is okay, but there is still a problem in the people who are working. The people who are working at UBC, I think, helping that signal are still in analog. Since they are still broadcasting VHF and UHF. But we are using a satellite signal. So if somebody sends their signal, demodulate it to the same signal, they make sure you maintain their resolution, and then make sure that once I put an antenna somewhere, I get all the 60 channels, whether they are 60. If you are using DSTV or StarTimes, you can't change the antenna to get some channels and fail to get some channels. It's the same. Whatever. So AM, FM is not something. And then describing the practical methods for the demonstration of AM and FM. Still AM, I will not talk so much about it. Then explain the physical effects of the CRO, then how a CRO is used, how beam XY, and finally explain the principles of regulators like thermostats, automatic switches, and remote controls. That would be the principles. On Friday we shall do the detail, we shall write down the detailed course outline as I explain each of the small sections and what we shall be covering, and then the next weeks, we have all the notes on weather, the videos are there. We should
can do robots before you go back. You do experiment R, which is robotics. You build it, and then after building it, you don't need anything. You only need a phone to look at the instructions. And then when you come back, probably you will be able to do. But you should.
I was checking on the online. I saw some of those how they were the steps they give you.
Yeah. The steps. They are small pieces everywhere. Once you have read those pieces, you add them together. Semi-phenol. This is gap. PHY3115, the capital. Everything is capital. PHY3115. That lady whom I talked about, I needed to give her a guest for us. If you go as a guest, you see the materials, but you won't do anything. You won't be able to do an assignment or anything.
I clicked on the test and the assignment, they were not working.
The test was supposed, that one is supposed to be those are supposed to be the past papers. And I have no past papers to, well, the idea, when I got it, the idea, you should have seen that if you are using Word Airways, you should have seen that you couldn't have that web page I have on any other course. The idea was that if I run a course like that up to the end, I should be able to make sure that once the exam is done, I get the PDF of the exam paper and put it under exams. I get the test papers, I put them as past papers, test 1 past paper, test 2 past paper. Assignments, so they are online, so those ones you pick themselves or you get, those ones are usable. You can't, even if I gave the same assignment, you can't say I had seen it because so they cannot move anywhere because I have not added any, for reasons you know. I have not ventured into making the exams, the past papers open, because some students will just decide to read past papers and not. I don't care if you got the past paper from somewhere, but not that you go around saying that, or you become confident that this is the past paper, these are numbers which some must come, and then you don't read to understand. My interest would be at least read and understand something. I heard Doroma's voice in the morning. Somewhere.
Somewhere.
He was talking to somebody, I heard the voice.
Here.
In my office. I know how people talk. I heard it. No,
I just talked to him in the morning, but he was very fast.
no, it's, I think I heard, was he in full?
He said he will be coming, was it?
At least I heard somebody like,
He was out to the way.
it was after lunch. Afternoon, like 12 or something. Anyhow, I'm being frank, the smaller the number these days, I feel like the better I become able to.
By the end of Friday, we shall.
Yeah, but I was used, sometime back I was used to numbers of hundreds, because I used to teach electricity and magnetism first year. So I used to get numbers. But there you they are just going and getting the basics, but you now need to get the basics right to apply and implement it. So we can make a bridge and robot now. Then when you come back, you do the other thing. Because for the bridge to build it and solder it, you are not going to depend on the course, are you? There is nothing in the course that is going to help you in knowing how to solder the equipment. I don't know whether you get my point. There is nothing we are going to study that will help you to know how to make a robot, to assemble the robot. There is nothing we are going to study that will help you, but assembling it will help you understand what a sensor is. Because one of the robots, I think I ran it here last time, is an explorer with the ultrasonic sound and the touch sensor. The other one is a line follower. It follows a line and it follows it, so it uses one uses a color sensor, the other one uses a light sensor. So at least as a transducer, in a sense, as an input transducer, at least you will know this is how it works. It makes some sound, so that's an output transducer. So you could do those two and solder. Or, because the fortunate bit is that even if it is the one of the LCD and whatever, still it's you have an idea of electronics. So me, I'm of the view that you can talk to Moses, and then during this time you talk to him, and then you do those practicals at your will.
These two practicals.
Four, there are six. Yeah, the other four. These other two we can, because for a robot I need to be there to help you at least know what eventually, and also confirm that it has worked. For soldering, you are only three, so each one gets a PCB, printable circuit board. You arrange your thing, you make it work. We test it with an oscilloscope and a transformer and confirm that you have changed AC to DC. At 12 volts, we expect you to get around, I think at 30, we expect you to get about 15 to 17, yes?
I have maybe something to inquire about. Now, for my sake, I'm not a teacher. When the term begins, I can always attend.
Yeah, you can always attend this.
Now, concerning the practicals, can't I also join this guy?
I have no problem. As long as you are available and you will be there, I group you up and I put you in a group and you come.
Always on Wednesday.
I'm going to choose Wednesday because it is appropriate. Monday is after weekend, hustling. Wednesday is middle of the week, and students would be able to be settled down. They would have prepared for that practical and whatever. And I'm grouping many 6, but we shall be having sets split because they are available. It's only one which is only one set. That is the one of experiment 19. It has a photodiode and an LCD. So I have no problem. Even these normal lectures, as long as you come and you are in, I have no problem. You study. I think some time back, one of the students chose to attend the normal lectures. And it is because you were skeptical. Had you from the beginning prepared yourselves to make sure you do the same paper like we did, you were going to enjoy the paper. If you had set your minds in
Our problem was this.
so the reason I've made you remain behind is to make sure that I expound a few things so that you realize where the course is taking us. And in terms of the project, since you are also people who are demanded of the project, and this is your final year, you have to start now. And then a project, I thought I had finished. A project is, I have a small analogy. Allow me to hint on it. I may hint on it with the other students as well in the future, but let me hint on it for about 14 minutes. I will be done, or 4:30. I use an analogy. I call it a cuisine analogy. Don't ask me how I came about it. It's something that I don't know. I don't remember how it came about, but I call it a cuisine analogy. Cuisine analogy. I think Mugume and Ronald maybe have. What is your favorite cuisine? Do you know cuisine? Favorite dish? What is that I come to your area and you cook for me? And if I told somebody I ate this, they know that that was eaten from Ronald's area.
Hello, what's it?
Hello and God's me. Okay. So, of course, goat's meat is not. Are you from? Do you eat shabu? Okay, let's look. For example, let's take a shabu, because a shabu is a cuisine, and then for Muruvu, where do you come from?
From here.
East. Musoga. So you are boy. Boy is what? Is the
Sweet potato.
sweet potato. And then the peanuts? Mayo. Why are you laughing? I ask people this to make sure they see how intimate it is.
Yeah.
Because when I mention Mayo, the person becomes excited because it's like, yeah, they feel you are into their what?
Yeah.
And that this is how I want you to feel it. And if I said I wanted a shabu, or if you told somebody that I ate ruombo, chicken ruombo, someone will know that you had visited Baganda. And that is the kind of, so we have a project has a title, okay? Like the way, so here is the deal. In these experiments, we give you instructions. So we give you title of the experiment, we give you the aim of the experiment, we give you the apparatus, we give you the procedure, we demand results, and then you can conclude if you want to conclude. Now, on the contrary, or on the other side, we change it. And when we change it, we now request you, first of all, we say, okay, it's okay. In the contrary, you are going to get your own title, and then you give us your own aim. So that we have a title, we have a background, which is like an aim, but it's not as if, but so after title, background, you tell us the problem you are trying to solve. So you have the problem statement, And in the new manual, I think this one of the background is also there. The new manual for our curriculum. And then there is what we call the aim or overall objective, and then there is what we call specific objective. This is not this is not casting stone. What I'm saying, this is not something that if a coordinator gives you a different way to present your work with significance, scope, you don't say that the other one will say about scope. So after this one, then you have to have literature review. And I don't remember where sometimes, I don't know where it is in between here, where you have the theory, but I think theory of the project should be around the theory of the project. And then where we give you apparatus, now it becomes materials and method. So this is method and materials. Some people call it methodology. Okay? And then after this, it means you, once you give a method you are going to use, then that method gives us the results. So when you get results, most often you discuss it. And then you can make conclusions and recommend where you didn't meet the recommendations. I mean, where you didn't meet the expectations you were trying to look out to in your project. The project is not a master that has to succeed. It can fail for many reasons. You had anticipated something, it didn't come out.
So when it fails, what happens?
No, you may want to produce a full wave rectifier and then in the middle you don't have the diode. You fail to get the actual diode, but you use some other diode, which gives you say, yeah, it worked, or you don't have the capacitor. For example, in this experiment you will do, I didn't put the capacitor because I'm not sure whether we will have the many capacitors to spoil, but the diodes are there. So if you wanted to get a smoothened output and you couldn't, you say I didn't get because I didn't have a capacitor. If I had a capacitor, I was going to get a good output because that filter, the RL filter, the RC filter would have helped me to filter out the AC part. The AC part, so that I remain with the DC. There could be some other languages in here, but this is so. When a student comes to me, for example, to be supervised, and they are fronting all the innovations, I want to build a generator, I want to build a motor, I want to build a radio transmitter, I want to build a radio receiver. I say, fine. What are you trying to solve? So I first take them through this analogy. We want to do a project, so a project should be having a title, should be having some background, the problem being solved, the aim, and then the specific objectives, which should be smart. You should have ever heard of this in curriculum, at least when you are doing your diploma. This should be specific, this should be measurable, it should be achievable, it should be realistic, it should be able to be done in a time frame. So it is time bound. So how do I come up with a survey of my day? So assuming you came here like the way you are around, you come here to Kampala, you are going to finish 3 weeks, you are not sure how you are going to manage your meals, and you want to get a way out. So you go to the Sheraton. Ronald. So when you go to Sheraton, you tell the manager, you say, you know, I'm from the West. This Kampala is full of West people. Those people eat shabu like nothing. I know how to make what? A shabu. But you have to give it a nice title. So you can say the Western dessert. you know, Western dessert.
Western delicacy.
Dessert, you know, it's a delicacy. Everyone knows, when you say delicacy, it sounds like it's not. You look for a title. The title should be somewhat. If you go to KFC, they give you drumsticks. What are they?
Thighs.
Thighs. But if you say, I want thighs, if you go to KFC and say, I want chicken thighs, how do they take it? It doesn't sound any interesting.
Drumstick is classic. Classic.
So you say, I want drumsticks, I want 5 drumsticks, and then you cannot say chips. What do you say?
Fries.
French fries. But these are potatoes.
Language is new.
Yeah, it's new to me, but that's what I want you to understand. So that's, you go to KFC, people are talking, and you can see the whole parking is full, the inside are eating, but they are eating the same things you can eat anywhere. But the terminologies and what and what, yeah, milkshake, what, when you go to KFC, I want milkshake, and then they do some, whether juice, I don't know what it is, then they give you to drink. Oh, you are taking the same juice you could have even done with a blender, but they are calling it cocktail. Then they put a slice of, they put a slice of orange or neem is lemon, yes, a slice of lemon like this one, the glass.
The straw is coiled.
And then the straw is coiled and they take all your money. So the cocktail, that cocktail, milkshake, drumstick is the way you have to, you can't say, I want to make for you my dough. You have to either say,
The Eastern.
no, you have to say either warm, gin and paste, or something that makes somebody want to run for it. And that's how you choose your. So you cannot say, I want to work on, you can't say making a radio. But somebody will say, design and construction of a radio receiver. But it is a radio. It's making basically a radio. Okay, at a lab level that you only have a circuit, and then once the signal is able to go across and then be received somewhere, then, or if you can be able to transmit and tune and get the signal, they say, I've got it. So a project, just like projects even at the application level, like if you say you wanted to tell UEDCL and do some project to improve the efficiency, someone can say, I want to do something that can improve the messaging. For example, I used to tell the Umeme people, why would you ask me the landmark where I stay? You came to install my meter. You had a GPS receiver. You have the GPS coordinate. You have Google Earth. You put in the coordinate, you see my house, even using the satellite imaging. And you can ask me, are you behind this? Are you the one in this long sort of rented place below the church? I said, yes, that's my place. Okay, we shall be at your place soon. We have free resources which we can use. But somebody is on voice, can you tell me the landmark? I'm near a school. What else? Which road is the fault at the area, or it is a personal fault? You get the, so you have the terminologies you see in those things of characterization of what is to make it, you are talking of the thighs, but you are saying drumstick. Spatial distribution of customers for easy access. Those all things are for making that.
So what is the background?
I don't know what they are now. I'm trying to lay the ground now. I want to come to the point. So how am I going to relate the project and the cuisine? So you come to Kampala, you are broad, you want to make the Western dessert, cheese dessert. Someone thinks it is cheese, but now it ends up it is shabwe. Or you can say shabwe extra. Whatever, how can you make this word sound nice? That's your title. The background is the way I started. So my issue is you want to go to Sheraton and convince the manager that you can prepare a shabwe and it will have many customers and it can be a part of the menu. And for you are going there thinking you are helping your Westerners, but for you are broke, you want to get some money. Project you'll be wanting to get marks and get partial fulfillment of your requirements for your degree, and then you pretend you want to be solving the problem. So you say, I want to solve the problem, so I want to design and construct A, B, C, D, and then here we are. You give it a title. You give it a background. Where is it coming from? What is making you do this? I normally give a story of some young man called Richard Turere. Richard Turere is a Kenyan Maasai boy who was in Masai Mara. Near Masai Land is neighboring Masai Mara. Masai Mara is a national park. With lions, it is. The Maasai look after cows. Lions like cows. So the family had given him a job of looking after the cows. So Turere started with putting effigies, his big kangaman, putting his big photos around the crowd, standing tough. The lions know how to look and they don't see any heartbeat, they don't see because you know they are killing, they kill by, they are smart. So they looked at the boy, they looked at all the boys, they are the same, they are not moving, there are no heartbeat, no blinking. They go on, they went in and took the cows. He put fire. In the night, the fire instead helped the lions to see the biggest cow. So one night he was coming to inspect with a torch. The lions took off. He chased them with the torch. They took off for their life. So he said, wow, how can lions fear a torch? So he tried to know these torches where, I don't know, these days we use cartouche on the phone, so we forgotten. This torch, I'm sure I don't know how to use this torch. Yeah. It has this and also a switch. There is full, or if you want to blink, blink. So immediately Turere thought of the indicator of a motorcycle. He realized the indicator of I think the motorcycle, because there was more accessible, something you knew you could easily access. So he made what we call lion lights. So he built, he says, in the video, I will share the video with you. He built he says he spoiled his mother's, I think, radio and battery to make sure that he gets wires and whatever, then he connected the disco lights, the flashing lights around the crowd. The lions feared for him. He did it for the community. They gave him a bursary. By then he was in primary. By the time he was presenting this, he was on, how do they call this? There is a community with, they call people and then they have a talk. I've forgotten, the thing has gone off my mind. It's like the way you say, it's like, it's
Baraza for what?
it's like a baraza, but it is an international thing. They have their, it's like YouTube, but they have their own website where they put their talks, key talks. I can remember later on. So I saw him on that. It is on YouTube, but also I had seen he was on that congregation with the Bazungu, and he had been from there. I don't remember whether it was US or UK, but you can see this innovation had taken him from. But it came as a problem. It came as an accident, but he was able to connect and solve their problem. So it was a win-win. Because if a lion killed a Maasai Mara, a Maasai land cow, they would hunt for it and kill it also. And even if it has not finished the cow, they recover the cow. So it would be a double loss. The Maasai would have lost their cow, the government would have lost the lion, and hence the income from the tourists. Now with this innovation, it's a win-win. The lions survive the killing, the people remain with their cows.
And you cannot forge his
Innovation. He called it lion lights. He didn't say flashlights or whatever. He now called it lion lights. The lights now which chase away the lions. Now, so I give that story to show you how innovative a project should be. So the background is that Western people who like Shabwe, who live in Kampala, who don't go home most of the time, they always plan around Sheraton here. If we make that menu, there will be a lot. So the man, so this is, there are many Westerners around, and they have money. The problem, they don't find the Shabwe to fill their home. Some of them, their wives are also less, they can't even make it. Even you can't find good materials to make it here. But me, I know. I will make sure it is young and fresh mold. A, you give an overall aim to make a Shabwe. Specific objectives, I need milk. I rest it for this long time. I be able to centrifuge it and then get whatever, eventually get a Shabwe. So those are specific objectives. Literature review. Where in Kampala can be a Shabwe? You go to Serena, you go to Kafunda, you go to Mama Mose, and see if so. That's literature. You are looking. Are you proposing what is already there? You are talking of a Shabwe at Sheraton, and in Serena it is even already known. It is even advertised on TV that. So that's where most Westerners are going for a Shabwe. So you first make sure you research. If it's like market research, before you, it is here in Uganda where people just hear this restaurant or fish, then he starts a restaurant. But there is supposed to be market research. And I can give you some hint also. Two people, a man wanted to open a shoe factory. So he sent two market researchers. They went out, they both found that the village was not putting on shoes. When they came back, A, he said they cannot have a factory because nobody is putting on shoes. B was excited. There is nobody with a shoe. We have a market on set. You see perspective. Two people went out for a market research. They both found no shoes. One says there are no shoes, there is no market here. Because people are not used to putting on shoes. The other one finds there are no shoes. He says these people, the moment we advertise shoes and show them the advantages, they are going to buy shoes. We have the market. So it also depends on the person. So So literature review is now when you are doing a project, you go to internet and say, has anyone constructed a full wave rectifier? Has any student here handed in a full wave rectifier? So that I do not repeat the one. So that's the same literature review. You are going to Serena, you are going to Sheraton, Hilltop, Skies, you are going to Munyonyo, you are going to Mistil, and then you say there is no shadow. So this will attract the Westerners. So theory would be about, okay, like how a shovel, you explain to this man, a shovel is made from milk, you have to get milk, do this much time, then do this process. You may not want to tell everything, but you need to. But in literature review, in a project, is not, I mean in the theory of the project, at times you start, most people try to talk about the materials being used. I'll use a resistor does this and this. And then, so sometimes theory of the project infringes on the part of the methods, because you are trying to talk about the theory about, it could be the whole project as a project, but also the theory of the components used. Some people sometimes confuse it with the background when we talk of the theory of the project. Methods and materials are the things you are going to use in your museum in order to come out with your nice model. Then the results and discussions. Results in the sense of the shovel is you get your bunch of Western guys, you bring them, some ladies, cute looking, some old men, some young men, and then you serve them a shovel. And you know how it feels when you eat something from home. You are like, wow, this is like my grandmother's thing. So already you'll be having the job. The man says, so results, then discussions, say, yeah, this, who made this? I want to see that person. It tastes like mom. You see, when you travel, like somebody will go to America and you find he's still living in Uganda. He knows where Kafunda, where he goes, buys matoke, then he cooks it himself, even or herself, then gets bumonde, then makes mugumba, and he's living his life in Kampala, but he's in US because he has kept in the. So if these people surely say that this tastes like the one at home, when you conclude and the manager concludes and says, you know what, people have loved your thing, you are hired, and then you start doing. So my biggest question after explaining to a student this analogy, when they come for me to supervise them, I ask them, would you now, what you are trying to propose to me, if it was a shovel, warm, mild, would you be able to secure a job at Sheraton? Because your dish, what this shovel that they are going to serve to these Westerners, is your project report. Will that project report be able to make somebody else make that same shovel and tastes that nice? Yeah. So this is what I want you to know, so that as you are studying these final courses, you start shopping from the courses you did long time ago, the courses you are doing now, and start seeing, you start pretending to solve a problem as you look for marks to finish your degree. So students normally come to me, I want to make a rectifier, I want to make a motor, I want to make a generator. I say, fine. Then, fortunately, the reason I have even asked you to take you through, the moment I take them through this, and they envision it from their local food, then they realize, no, I need to do something that will make this manager want to retain me and I make some money. It is, you know the reasons. You know the reasons. When people are making project proposals, these who write to donors, they know they are in nano problem, reasons. But they make sure they pretend they want help or funds, but they also want to build big houses. But they will write, we shall get children from each sub-county, pay for them fees. When they get them, they almost end up taking photos when they are in drugs, then they buy them some small and children. Okay?
Yeah, it's understood.
So now I wish you good luck in looking for the topics that you can get. At least from my perspective, I don't care whether you go to internet and get a project and then you reproduce it to solve a local problem and apply the local knowledge you have acquired using that project. Not that you are getting a project report and a project set up and then you come here and build and then you say, me, I did. No. Can you contextualize it and then go through the same process? To me, you would have gotten the skill. After all, we are using the textbooks from abroad, getting the knowledge, but when I do the exam, I supervise you tightly to see whether you can reproduce that knowledge. Then I will know at least you have an idea.
Thank you.
You're welcome.
When is that by the way? Is it next semester?
Yes, next semester is, we'll start with proposals, then you start. So the earlier you start, the better. You start surfing now, get whatever, see whether it can be a cuisine, a moderate cuisine, and then after seeing it in that mode, you start pursuing or getting a supervisor who will be able to guide you. A supervisor is a guide, is a person who helps you to put your ideas into practice.
So you choose your own. We are given the liberty to choose from any.
Yeah, the supervisor. Yeah, you choose from any who is willing to, whom you will benefit from. Benefiting, I mean, you don't want, I think I've already explained that it is not just about marks.
Yeah.
That you want marks and then you go away. It's about finishing and then be able to understand something, and also remember that the supervisor should be a person that you rely on in the future. That you are able to ask something, not working with somebody, and then you part like they say in our local language, they say parting like the ash and the leaves. You use the leaves and the two will never mix. So, so I don't want you to be in that category. Choose somebody who probably in future you can be able to work on something bigger, or if there is an opportunity, you will be able to expound on your own. So, I wish you a good night. Now I think I have initiated the working now. My working spirit has come.
At least you now say to the Lord.
Yeah, you don't wait for the last time. Just look at potential projects. Then look for the write-up, look for the circuit, even if you got the circuit from the internet.